It's Tui here, and we are working still with Tui Time Graphics. We have camera working, moving stuff around. We have the model being able to be moved around, pretty cool stuff. You can see the vertices being drawn, pretty awesome. I think in the future episode, I'm just going to do a recap. Like I'm literally just going to not code and just recap everything we've done so we can summate everything together, and then we'll move on from there because we're going to start getting into some more complex stuff. However, today shouldn't be that complex. Today is just going to be making or applying textures to objects. So what a texture is it's basically an overlay to any of the vertices you have on screen. I figured I'd do a quick video. I'm sipping pre-workout right now, so if I take a sip every few seconds, I'm sorry. But I had some time on my hands, so why not record a quick video and let's draw some textures. All right, so oh, that's really cool. Yeah, so what a texture is it wraps it. My goal is to put this smiley face that I found online. I just typed smiley face and that came up and I liked it. And I don't know if that's stealing, if I should reference that site. I don't know. I might, just in case. I don't even know where I got it. It was a little while ago. Oh, well. I'll deal with the lawsuits. All right, so, yeah. This will be wrapped around this. But to make it a little easier, because cubes take a little bit more time, we're just going to comment out everything for the cube. We're going to comment out everything for the triangle, and we're going to comment everything out for the, nope, we're going to use the plane. So we have our triangle, this goes up here. We have a plane, a triangle, and a cube. I'm going to create a node. I'm going to create a new group called shapes. Primitive shapes. And I'm going to add these three in there so that I can do that. And then this stuff is nodes, but they're not really, I can add the primitive in there too. Trying to think of what to call that, because we have node, camera. These are nodes, but they're, you know what? I'm going to figure out a naming scheme, maybe an optimization later. Screw it. We're going to put them on the outside. We're going to get rid of this. Sorry. That was a waste of time. All right, back at it. So we're not going to draw cubes in our basic scene anymore because I don't want to draw cubes yet. It's just too, we're going to apply texture coordinates. You'll see in a second, but I don't want to draw cubes. Instead, I want to draw a plane. So I'm going to say var quad, which is a plane, because it has four vertices, or four vertices, 4 points. So plane, and then we're going to instantiate it right here. So quad equals plane, device, same old stuff. We're going to add the quad, child, quad, and I'm going to press play. Oh, well, okay, so we have, from the last episode, we have all these rotations. I'm not going to delete them. I'm just going to comment them out for now. We'll change the name if we need to. And, yeah. So I think it might break. Maybe. No? Okay, so we should have a plane just kind of right up in our face. Oh, well, there it is. Right. Oh, that's interesting. That's very interesting. All right, so, it's because I have my rotation on. I was like, why is it shaped like that? Anyway, so we're going to put a plane on the screen. I'm going to get rid of this rotation stuff because it's just distracting more so than anything. And I'm going to go quad dot position dot z equals -4, 3. We're going to -3. I kind of want it to fill the whole screen, but I don't want it to fill the whole screen entirely. I want to have some gaps, so let me see. Sure, that works. That works just fine. All right, so we have that. We have exactly what we need. Now, let's apply a texture. So in video games, when you see this bottle, you'll see that it has this. See how it has this wrapping around it. This is oh man, this is perfect. This couldn't work that any better. So I want to apply a texture to this basic bottle. Well, I'm gonna go and take this and wrap it around. This is my texture, and I'm going to wrap it around just like so. This bottle has vertices all over it. If you were to, I mean, it has a lot of vertices, but if I were to take this bottle and say, I want this point right there to have this Nestle on it, then I would say this point would be right there, and it would be like that. So this texture coordinate applies to this vertice. Does that make sense? So that's what we're going to do. We're going to apply this wrap of a texture over our basic objects. And it's not the hardest thing in the world to do. It's going to take a little bit of code, but it's not the hardest thing in the world to do. Okay, so I'm going to draw some stuff. Not GitHub. Don't need you. I'll leave you open. So I'm going to stop you. Go back out to this. Okay, so the way the textures work, we have our basic scene, right? So here's our screen you're looking at right now, and then we have our clipping space, which goes from like -1 to 1 to -1 to 1. We have, let me move that down. Okay, so we have our basic -1 to -1. So this is -1x, +1x, positive blah, blah, blah. You know, this is your clipping space from 0 to 1. And then if we drew this plane, we would draw the plane at, how's this look? That looks fine. All right, so if we drew this plane, we would draw this plane at -1, +1, 0, right? So that's this coordinate, and I'm going to do that for all these guys. So this one would be 1, 1, 0. So I'll put that right there. This one would be 1, -1, 0. And this one would be -1, -1, 0. I'm saying 0 because it lies right on the z-axis, right on the z-axis origin. All right, so that's these points. I'm actually going to put this right here just to kind of signal that that's what this represents, these points. Now, texture coordinates, however, I can't do opacity, can I? Can I do opacity? Oh, I can. Cool. We'll do that. So, say I have this, oh, I'm not going to do that. So, say I have this, do that. Let me get brighter, I guess, and then we'll go down up to maybe right there, and go there. All right, so now, say I have this texture that I want to apply, right? I have this texture. I want to apply it right there. Well, it doesn't use the same coordinates. As of right now, actually, it uses, so this is the origin for our normal screen. So our origin is right here. This is our origin, right? 0, 0. But when you're doing a texture coordinates origin starts right here. And I don't like it starting right there because if you take a look at any image, so if we were to put the origin right there and then the origin on an image is down here, well, it would like invert it and it would be upside down. So we actually want to put this origin right there, and there's an easy way to do that. So say this was our origin, so this right there would be 0, 0. Oh, I want to change color. 0, 0, and then there's no negative texture coordinates. It's all from 0 to 1, 1. That's the texture coordinates. So let's go right here. We'll go 0, 1. Oh man, come on. Come on. What are you doing? There we go. 0, 1. And then right here would be 1, 0. Okay, so keep that in mind that these are the texture coordinates because they start right here is the origin. Right there is the origin for the texture coordinates. Okay, and then this is the origin for the object, for the entity, the node, whatever you want to call it. That's the origin. So what we're going to do is we're going to apply that same logic over here. Now, Hope that was a good enough explanation. That's the best I got. Alright, so I'm going to put him kind of in my view because I'm going to use him in a little bit. Right there. So, yeah, so let's get into it. Just like we did renderable, we're going to make a texturable protocol. So I'm going to go to my 2time graphics, say new file. I'm going to make the texturable protocol because we're going to have similar functions for all texturables, and they will all just have a texture. Fairly easy stuff to kind of break down. All right, so import metal kit, and then we're going to go protocol texturable, and all the texturable we'll have right now, we'll probably add some more stuff in the future, is just the texture. So var texture, make sure it's var so you can change it. MTL texture, and then we're going to make that optional equal optional, and then we're going to say we can get and set it. Okay, so that's easy. Now we're going to extend it because we need one extension method for this right now, texturable, and we're not going to write that yet. So when we have, say we want our primitive, we will have our primitive. So let's see, so we'll say extension primitive texturable. We want our primitive to be texturable so we can wrap our primitives, our cube, our plane, our triangle with a texture. So, but we need to also say up here needs to have texture, MTL texture, just like above. So now that we have a texture, we can put a texture over this, and we can either have it so we don't need to pass in a texture, or we do need to pass in, either or. If you just want to draw a random cube with nothing on it in your world, you can do that. Blah blah blah. All right, so I'm gonna actually make this a little nicer so that it doesn't look so. Just do this. I like doing that. All right, so now we have our primitive renderable. Blah blah blah. Now let's go back. Now we need the ability to set this texture, and so for every single texturable object we will have an image associated with it, or like an image, probably an image. I don't know if there's another way to add a texture. I think that might be the only way. Maybe not. I could be lying. So what we're going to want to do is set the texture. We'll get the texture from maybe a file. Yeah, a file over here. And then we'll need to load it into this MTL texture. And it's not too hard, so let's do that. So we're going to write in our extension function, because every texturable will do the same set texture. Func set texture. We're going to pass in the device, because you need a device to make a texture loader, or a new texture, excuse me. That'll take an MTL device, and then we'll need the image name, which will take in a string. This will return, just like we did on our renderable method, we return the render pipeline state. On our texturable, we're going to return exactly what we need. So MTL texture right here, and then we're good. So I'm just going to create those real quick. So we have var texture, MTL texture, like that, equals nil, and then we're just going to return that so it's happy. So it doesn't return texture. There. So now that we're doing that, cool. Yes. So the way in which we're going to do it, we could probably cover this in a future episode. I mean, the best way to do it would be now, but I haven't. Let's go. Let's do it. Let's see what we got. So MTL texture. Sips and pretty. Exercise is important, devs. See, so we have all of these different things for this MTL texture. We want to call new texture on it, so that's not actually here. But let me see if this has anything that looks good. No. Really, I mean, you can look through this, but applying these textures isn't the most complex. I wanted to show you some stuff that I found, but I can't remember where I found it. So So we need to populate this texture, right? Because it's, as of right now, it's not even being used. So let's populate this texture. So what we'll need is a texture loader, and the texture loader comes from the Metal Kit texture loader. Metal Kit has a really badass library for doing this. So we're gonna say let texture loader equals mtk texture loader, and then we're gonna pass in the device. See, not hard. I think that's what it. I hope that's what it takes in. Yeah. All right. So now we can call. So I don't know if you've ever used the resources like bundle.main.url or like just to get the resources from our file structure from this image name file structure. It's pretty easy. But what we're gonna need is something called a URL for this. So it's gonna be like I don't know, what does URL stand for? I don't know if you know that. If you know that, good for you. URL definition. I've never actually looked at this. So it's like relational. No, that's not the one that I need. I need the acronym. Oh, Uniform Resource Locator. So that makes perfect sense. Uniform Resource Locator. So we have resources in here, and it's going to find that resource for us using this URL path. So I'm going to say let URL equal bundle.main.url. URL. And then, I think this is right. Bundle.main.url. Oh, here we go. Yeah. And then for resource, and then that will pass in the image name. And extension, like we're not gonna do this, so we're just gonna pass in no. We'll just put .png or JPEG, whatever we're using. So now we have a URL to navigate to in our directory, and now that we did that, we're gonna have to wrap this in a try catch, just like we did in our. Where are you? No, it's in our primitive. Just like we did for the making the pipeline state. I thought that was in primitive. Oh, yeah, but it's not in primitive, it's in renderable. Just like we did here, where we caught that to make this render pipeline state, we're going to need to do it here in the texturable. So do texture equals try texture loader dot new texture. Oh, and there's a bunch of options that you can use if you need them, but I'm going to .new. It's not new. And then I'm going to use with contents of URL, pass in some options. So URL, unwrap, and then options, I'm just going to put this for now. I'm not going to put anything special. And we're going to have to catch that. Let error as ns error. And then we're just going to print problem or failed to load texture. And then I will put right here. That's not how you spell error. Error. Cool? You happy? No? You're not happy? Maybe? Is that wrong? That's wrong. Oh, we don't need that unless we're, nah. Nice. Okay, screw it. I'm just going to put error for now because I don't care. It's going to work. I'll fix that in the future. I'll have to go through all of these classes and just kind of fix some stuff up, tidy some stuff up. All right, so now that we have all that stuff, our texturable is ready to go. Look at that. We're going to return this texture. One thing I do want to do before I do any of this stuff is wrap this whole function to check this image name. So if image name does not equal this, oh, well, that's not Java. Used to JavaScript. Move all this stuff up in there, And so now what's going to happen is it will say if the image name does not equal empty string, then do this stuff. Else, just return a null texture, and then it won't apply it on the in our GPU stuff. So pretty handy stuff. Yep, cool. So our texturable is now done. There's some stuff we'll have to do here. We'll have to actually create some options and for the origin, but we'll do that in a second because I just want to show you what happens if you don't. So yep. Let's go set our texture on our primitive. Sound cool? Sounds good to me. All right, so now on init for our primitive, we're going to need to take in an image name now. And then that could be an empty string because if let's texture equal set texture device image name self.texture equals texture, and then we're going to use a different fragment function because our this fragment function that we're going to create will take in textured. This new fragment function will take in or will be for stuff with textures. Else we'll just use the basic one that we don't have textures on to apply textures to. So that's cool. So now we have our texture. We're probably breaking on all of these now because when we create, actually we're not. Cool. I'm gonna run it. I'm just gonna see if, oh, it looks like we got one error. Yep. So when we make our quad, we're now gonna need image name. It's gonna do the shortcut by doing it this way. For now, I'm just gonna pass in an empty string because we don't want to apply the texture. We just want to make sure that it runs. Oh, where are you? Oh, geez. For that triangle that we have that color for. All right. Well, I'll just have to remember this if I ever change it. Oh, good. Okay. Boom. Let's build it. Sip some free. Okay, cool. So we're still loading. Obviously, we're not loading any textures, but it's not breaking. It's still using the correct fragment function in the GPU or in the shaders.metal. So it's still using this basic fragments. Let me comment this out. I don't like yellows. That's annoying. Okay, that's better. So let's go back to our primitive and talk some more. So now we have our textured fragment function. We'll need to make that. One thing also that we need is a sampler. So what a sampler does is, let's go to patina. So say we're on the GPU and we have this plane, right? And we've put all the vertices because we used our vertex shader to put our vertices where they want. Now what our sample function will do is we'll say this right here, this guy is our texture, okay? It will take the pixel at this point right here, that one pixel, this is 1 pixel, sample it against whatever we have in our vertices, like in this fragment, and then it will say, bloop, that's what it should be. Put it there. Next pixel, bloop, right there. So that's what our sampler is going to do. So when we sample something, we're sampling our texture against our whatever we've created through our rasterizer. So we need a sampler to do that with, and so let's do that. We're going to do that in the renderer because it's pretty basic. It's something that everywhere will need if it needs it. So we're going to do it at the very beginning. So this will be func build sample state, and it will be just like, okay, I can show you this, and I reference this all the time. So if I go to here, oh, maybe not that one. No, it's this one. So if I go to there and I go to the buffers and textures, my computer will click up. Did I click it? There it is. So if we go here, nope, I always do that. Darn it. Where are you? Graphics renderer, come in. What do you have? Yes. 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 Let me see if it's on here. Depth, stencil, render, vertex, fragment. No. I know for a fact it's on the fundamental concepts. God. Here we go. Goodness, let's see. Sampler state. So just like we made the depth sampler state, we're going to put the sampler state in the command buffer. We're going to have a bunch of textures to apply to put them also in the command buffer. Well, render command encoder and then the command buffer, obviously. But the sampler state will need to pop in there. So that's what we're going to do. We're going to pop the sampler state in there. So we're going to build the sample state, take in the device just like above, mtl device. And let's build the sample state. Let sample descriptor, just like we did before, equal mtl sample state, or well, sample descriptor. Okay, easy peasy. So sample descriptor dot min filter. Okay, so how do I describe this? There's the min and there's the mag. So the magnitude and the min, like small. So the way this works is when you zoom in on a picture really close, you'll see pixels, right? But say you zoom out really far, you can't really see those pixels. When you stretch an image, right, you're expanding how many pixels are inside of that image. So it takes more images to fill those spots. So you go from small and you're going large, you need more pixels. You need more pixels to fill in to make it stretch. Well, what the min filter and the mag filter, min filter is for if you shrink it, mag is for when you get big, but what it's going to do is it's going to say how I'm filling these pixels. That's what these filters are. So there's two different ones. There's linear and nearest. All right, and so what linear will do, it will find an average of all the surrounding pixels and color itself like that, so it looks more like blended. If you do nearest, it's going to find the nearest color to whatever like is around it. Wait, that might be wrong. Linear might be like from one point to another point, kind of like a gradient works. That is how it works. And then nearest would be like it just takes an average of all the pixels around it and then colors itself that. So it looks really bitty and really pixelated. But that might be good for the texture that you want. But for all of ours, and what I'll do is I'll do both. All right. So we'll do .linear sample descriptor .mag filter equals also .linear. And we'll go through both before the time is up. And then I will say, oh, we need a sample state. So I will say var sample state mtl sampler state. I should probably call it sampler, not sample. Build sampler state because it's a sampler. Like your refrigerator is a refrigerator, not a refrigerate. All right, so sample state equals device dot make sampler state. And then we'll pass in the sampler descriptor. Okay, just like we applied the step stencil state, we're going to call build sampler state, pass in the device. And just like we built the depth stencil state down here, we attached it. We're going to attach now the command encoder dot set sampler state, fragment sampler state, and we're going to say sampler state. Okay, just like this, we just applied it to our rendering command encoder, boop, right there. And now we can put textures, all the textures we want in there and use them as we wish, as we need to, okay? It's yelling at me. Hold on, I'm gonna do this again. Dot set. Oh yeah, so also you can have multiple types of samplers, right? So we can have two different ones that do both linear, nearest, linear, blah, blah, etc. But what we're going to do is just do one for now, and we're going to put that at 0, and this is the buffer index for the textures. You'll see that when we go into the texture, or when we go into the shaders.metal class, but this, we're going to put at buffer, or texture buffer 0, something like that. I don't know if that's how you say it. But just like we did in here, and we set these at buffer 2, buffer 1, we're going to set them at texture 0 and sampler 0. So, yeah. So, go GPU for being fast and awesome. We now have a sampler state. Let's run it make sure that nobody breaks. It shouldn't, because we're still using the other fragment function, so shouldn't break. And we are good. Let's continue. What else do we need? Well, we have our texture. We need to put our texture that's what we need. We need to put our textures into the render command encoder. And in our primitive, it's very easy to do. Once we have our texture, we can just say command encoder dot set fragment texture, which is our texture, at texture buffer 0. Because this is on the fragment now. Remember, we're not on the vertex, we're on the fragment. Okay? So let's go to the shaders.metal, and I think we are like now that we've set this fragment texture from whatever we've built up here, we can now go down here and build our function. Cool, huh? So I'm gonna copy this exact one right here. Just put it right there. And this will be for whatever I called it here. So I called it textured fragment function. Okay, so we have our vertex in, our vertex out, which will, we also need to do that, but we'll do that in a second. So now we will need to take in both the sampler and the texture. And to do that, let's do the sampler first. So sampler, easy, we'll call it sampler, and then we'll say sampler at 0. That's pretty freaking easy. For the texture, okay, so this is a 2-dimensional texture. I think you can have 3-dimensional textures to wrap 3-dimensionally maybe. I have no idea. I've never done that. I've only done 2D textures because I'm simple like that. We're actually going to look up other types of textures, because if it's like a circle, it's going to have different, it's going to be more of a, it's not going to be such a flat square. It's going to actually kind of be a circle looking texture. So I'll see if I can look that stuff up. Actually, I'll do that right now. Anyway, no, we're going to build this. All right. So we're going to need to make it a texture 2D, right? And then we're going to use float as our texture coordinates, right? So this will be texture. So this will be our texture. Literally, this is the image. The texture 2D is our 2D textured image. So in our case, it's the smiley face, right? So texture, and then just like I said, we're setting at the buffers or at the sampler, we're going to say texture at 0. Yeah. So now we can use this stuff, right? But I'm not going to yet, because there's one other thing I need to do. We need texture coordinates. Look, we need these texture coordinates. If it doesn't know what the hell these are, how are we supposed to do it? So just like I applied it here, and this is why I needed this to stay right here. We go back to our plane. These are the vertices, right? So let's apply these texture coordinates also and pass them to the GPU, because the GPU can do stuff really quickly. So in our types, we're going to go here. We're just going to say var, and then we're going to say texture or text chords, because I'm lazy. No, I'm not lazy. I just don't want to type the whole thing out every single time, which is lazy. Those are going to be a float too, just like you see here. They're not going to be 3-dimensional. It's going to wrap to the vertice, so it'll be 2-dimensional, and then wherever the vertice gets manipulated, it will stay with that vertice. Pretty sweet. It'll be float 2, and now we're going to get a lot of complaining from our plane saying, "What? I don't know what that means. What's a text chords? Add that." So here we go. Boom. And then we're going to go float 2, like so. I'm just going to put 0, 0 on all these for now, because quicker, and then we're going to copy and paste this guy in, and we'll set them. So I have these labeled V1, V2, V3. I don't know what the hell that means here, but if we go here, we see our X and our Y, right here, our X and our Y. So this one was 1, 1, 1, 1, we're going to have 1, 1. See that? So for 1, 1, we need to put it at 1, 1. For negative 1, 1, which would be here, negative 1, no, excuse me, negative 1, 1. We're going to have 0, 1 associated with that one. When you do object files, it'll do this for you automatically, so you don't need to actually do this, but since we're not doing model IO yet, that's coming quick because that's some cool stuff. Before we do lighting, I want to do model IO. You'll see we have that. Now we have, what do we have? We have -1, -1, which is this one, so that's 0, 0. And then we have 1, 0, which is, wait, what? Oh, we have 1, -1, which is right here, so 1, 0. Okay, and you notice that none of these are touching the same thing. Beautiful, indices stay the same. Now we have texture coordinates flying through here, which means in our shaders.metal, we also need to have a texture coordinates flying into the GPU. So we're going to attach an attribute to, this will be text chords, and vertex out will have to have text chords. Okay, cool. All right, so remember how we're taking stage in for this vertex in? Well, we're going to have to update our vertex descriptor to be able to know what the hell is at the second attribute. So let's just do that real quick. This will be 2, 2, 2. This will be a float 2, and we will just do this one plus this one. So this will be the offset of this guy, so which will be float 3 plus float 4. So I'm just going to copy this plus that, which will be a float 4. And the stride stays the same. That looks good. Now, let's build. Oh, yeah. That was kind of gross. Trying to make this nice and fat. Oh, cool. So everything builds. We have our freaking cool vector vertices still drawing. Cool. Cool. Let's just kind of evaluate where we're at right now, okay? Okay, so the only thing left to do, I'm going to keep that, is our fragment needs to return a different color now, right? Our fragment needs to return the texture's coordinates color. So whatever fragment I'm at, we need to return that texture like I drew before. And not the orange, blue, green, whatever those random colors are. We need to return the image. So like I said, we're going to use our sampler to sample our texture. All right, so the texture has this built-in texture.sample function where you pass in the sampler, oh, well, I'll put sampler, and then I'll call it 2D. Taking the sampler 2D, and it will take in the coordinates, so the vn.texture coordinates, right? So that is literally going to find it's going to take that texture coordinate, take the sample that, return that color at that fragment, because this is per fragment. One other thing we'll need to do up here is go vout.textchord equal vin.textchord, so it goes out to the fragment. That's simple. All right, so this will be color, right? So float for color equals that sampled color at that image. And yes, we could take this sampled color and multiply it by the color we pass in. So if we wanted grayscale, we could use grayscale color. If we wanted any type of color, we could. Right now, we could use the red, green, blue random colors that are also showing. We're not going to do that. We just want this image, okay? So I'm going to use this smiley face. That looks about it. I don't think I need to do anything else. We just need to sample this texture color and then return that color, okay? Simple. So let's make a new images file, group called images. And let's throw smiley face man in there. You can choose any image. This guy's 128 by 128. I've noticed that, and I don't know why this is because I haven't looked into it, but I noticed when you use like a 350 by 820, some of the colors get a little skewed because it's not perfectly square. I don't know if that's totally accurate, why the reasoning was. I couldn't figure it out. But if you have any input, let me know. I'm going to also show you real quick. So we're going to look at 3D texture wrap example. So if we go to images here, you'll see, let's see if we can find one that looks, "3D texture wrap graphics." See this? Okay. So you'll notice when you make this 3D oh man, that's kind of cool. It's pretty realistic. But you see, it's not like a perfect, it wants to wrap it, but like it has to make it weird looking. You see, this doesn't, these right here are texture coordinates, by the way. Those are the texture coordinates. All these little vertices looking things, that's texture coordinates. So it's mapping this to like right there. And so it's going to take this texture coordinate, put it like right there, and then it's just going to slowly wrap it around. You see how that works? This doesn't have real shading. It's using like modeled shading because he's drawing, obviously, to do it. But in our graphics, should be doing shading dynamically, not this fake shading. But you'll notice like the ears are way off to the side because they wrap all the way around his face, you see? So it doesn't necessarily need, and here's the under of his nose, like it needs to wrap that under his nose. It doesn't necessarily need to be a perfect texture like we have with our smiley face guy. Okay, so yep. Now I think if I were to go to my basic scene, type here smiley face. I hope this works. If it doesn't, we'll figure it out. .ping. If I go ahead and press play now, it's going to fail. It's going to say, dude, what are you doing? Oh, okay, so vout.texture coordinates need to be at float 2. Your float 2. Was talking too much. Look at him! Oh! Zoom in and out, I can move him around. Look at him go. Sweet. Look at him go off in the distance, come forward. Alright, so remember how I said the origin is now at the top left? And so the origin of the image is actually like right here. Or, well, I guess the origin of the image is right here, and it 0, 0 matches up with 0, 0. So it's upside down. Now we want to take this origin and we want to move it to the bottom left. And there's an easy way to do that. It's just using these options. Okay, and options are dictionary format. So if we go back to our texturable, let's make some options. So we do it. I'll do it after the URL. So let origin, we need to make the origin equal ns string ns string, and then the ns string is going to be mtk texture loader option origin. Okay, and then we're going to make the options. Let options equal mtk texture loader option origin bottom left, and then we will put the origin. And now we have options, so we're going to pass that in as options. And press play. Slip some pretty. Get hyped! Oh, did I break it? I didn't do something right. Yep. I'm a goose. That goes there. This goes here. We want to put the option origin at the origin. My bad. The origin is going to be the bottom left. And alright, so we are using linear right now for how big this guy gets. He's only 128 by 128, but when he fills this whole screen, you know, he looks, I mean, it blends. You see how it's kind of using the, like, it's very blended. Now let's go ahead and go back to our renderer, and instead of using linear, we're going to use nearest. Okay? And we're going to look at the difference. And you'll notice it probably looks more bitty. See? So now it's not blending. It's literally taking the average and just like, I'm that color. Take the average, I'm that color. You see, it's super pixelated. I mean, you could probably use that to get whatever. I mean, if you want that effect, you can use that effect, but we're not going to use that because it looks gross for this case, at least. Use linear, go back. We won't see it nearly as pixelated. It'll blend together. It'll use more of like a nice, smooth transition between colors, and we don't get those bit pixels. So, yeah. So there's that. But I don't know what you and like we can let's do this. We can go back to our basic scene, and let's rotate this guy. This is quad now. Actually, you know what I'll do? I'll just name it C. I know it's not C, but screw it. Everything else is already kind of named C. Now let's rotate this, and we'll notice that. Oh, look at him. Oh, look at him. He's on both sides. It's rendering on both sides. It's not necessarily a good thing because, you know, it takes more processing power to apply it to both sides. If we were to go to the renderer, probably not going to keep this because I don't want to. We'll do it if I need to. But if we go command encoder dot set cull mode and we go dot back, it's going to cull the back. It's going to not draw the back of whatever. And then I think we actually need to set the counterclockwise values on the drawing. Yeah, see, so that was the back. Look, no back. But wait. Oh, no. So apparently we're calling the wrong one. Let's do front. So it's going to cull. That doesn't make any sense. Was it already rotated by the time it loaded? Something's up. Anyway, the culling, it's culling the front. I guess maybe drawing the front. But then it won't draw the back. But it'll draw the front and not draw the back. See, that's how that works. But we're not going to do that yet. We don't need to worry about that because I want to go to my. I want to do the cube. I think this plane's cool and all, but I want to wrap the cube, and there's some stuff I need to show you with the cube. So let's undo our cube and trying to remember, do I have those somewhere? Because now we're going to have to go through all these vertices and wrap that texture to it. Just thinking. Okay. So okay, I made this already, but unfortunately I didn't save the example where it shows you issues. So I already planned to do this. Okay, so remember how we're drawing 7 right now? Right, we're only drawing 7, we're indexing them at their spot so that we don't have to draw multiple vertices. But what that does, if you think of a cube operates a little differently. Because if you were to wrap, let me do a cube. If you were to wrap a cube with a picture and you use the same vertex every time, well, this image would then wrap to it in several locations. So say, I need a cube. I don't have a cube. I got that thing. I'm not going to use that. Say on one flat side, you had the origin down here, right? The origin's down here. This is the flat. This is the face. This is a smiley face facing you, and this back over here is the side, right? So here's the face. Here's the other face. Now say this right here was the origin. Well, it's straight up, but this texture coordinate for this one would not be the same texture coordinate for this one. So it would have to come all the way over and invert itself. You see, so when drawing three-dimensional objects, using the same vertex over and over again sometimes can't actually work because this cube is going to need to, it won't be as smooth. And so what we need to do is not use these vertices, but to save time, because sometimes these videos can run pretty freaking long, and I did the calculations already, and you'll want to, like, this is entirely different, by the way. Entirely. You'll want to use these ones, and I'll leave this on the screen for a second so you can pause it. I'm using 0.5 now. Actually, I'm not even going to use that. I'm going to use size still. So I didn't think to do that. Give me one. So you can watch me code for a second. So I did this to save time, but it doesn't save much time. Float. Actually, I think I can do it on here. Yes. Let's just do it on here. So here's my thing. So let's go here, and we'll go Alt down. See, I need Notepad++. I'm going to go get Notepad++. I don't want to pause either, so you're going to watch me get Notepad++. Okay. Yeah, so what we need to do is we need to draw more vertices. I reset my computer, and so now it doesn't have nice. Let's go here. Oh, Windows. Can I not get Notepad? Oh my God, I can't. But Adam. I use Windows at work. I forget things, all right? Gotta know so many different languages, and so we're gonna use Atom. Atom's like my favorite anyway. I love Atom. I love that it's open source, and I love that it supports so much. That's gonna take 2 minutes. Oh gosh, I bet I could do this in that same amount of time. So if I go here and I go size, and then I go like this is gonna take. You know what? Screw it. We're gonna use 0.5, and then next episode you can put size if you want. I'm not gonna do it. Oh, I didn't know Atom would take years to download, so sorry about that. Anyway, off topic. We're going to use this. Boom. That looks good. This isn't texture chords. It's text chords. Boom, boom. Hopefully this works. Try to make it fast, longer, or shorter, but whatever. Now we're using different indices. Like, it's the same exact style, where this equals, I wasn't so fancy in organizing this one. You don't have to do this, by the way. Look at how many indices there are now. Remember, the other one went up to like, I don't know, 8 or 6, and this one's gone up to 22 because it's just 0. Like it's basically using every vertex, unless it doesn't have to. Okay, so yeah, ignore that float. Let's switch this out with a cube in our basic scene and just see what happens. So instead of drawing a plane, we're going to draw a cube. Cube, play. Let's see what our cube looks like wrapped. Woo! Look at it. Look at. Uh-oh, he's upside down. He's upside down too. See, but the thing is, I could fix those. Shit. I knew that it would work, but I'm not going to do that. That's what it's going to look like for now, because in one of the future episodes, what we'll do is we'll just make our own objects, pass them in, they'll fix themselves. But for just demonstration purposes, this is how we're doing it. Yeah, let's take this guy, uncomment him, press play, and now we'll see more rotation. Look at that. It's freaking oh boy. There he is. And if you notice, if you press this little wireframe button, look at the colors are, see, it's using those colors. Let's go back to our renderable, or excuse me, our shaders.metal. Let's go down here. Let's take these float intensity, and then we're going to take color equals color times intensity. So now we're going to use the light position to like shine the light on it, and it's going to work exactly the same because that's just how it works. Freaking cool, huh? So sweet. That's awesome. So that's textures. I hope I didn't forget anything. We'll get into more textures later as we discover more stuff about, you know, drawing graphics. Oh, let's just play around. Okay, I do want to play around because this is kind of fun. So in our basic scene, sorry, got ahead of myself. So now in my basic scene, what I want to do is I want to draw a var wall as a plane, right? So I want a wall now. So I can say wall equals plane device image name will be that for now. Let's go. I have some images down here that I've already got. Let's look through them. Don't want to go through all my files in front of you. Don't know if there's not really anything too crazy on this computer anyway. Let's use let's use this stone image. So I'm going to take this stone image, throw it in here. I'm going to make the wall be made out of stone. And then I'll say wall.position dot z equals -10. Then I'm going to say wall.scale equals float 3. We're going to scale it by 5, I guess. Right? And then we're going to add the wall. So add wall. Child wall. Woo! So now, oh, okay, all right. Oh, it does not like that, does it? All right. Oh, okay. So we ran into this issue where it's trying this and it's saying go to hell. I should have just printed that error. It shouldn't have broke. Oh no. It's trying to unwrap nil, right? Optional found nil while unwrapping an optional value. All right. So I know what the issue is. We'll have to figure out some sort of a break for that. I've got to get off. How about the time? 58. Might be the shortest one yet because we're about done. Let's go here. It's stone, but we got to do stone.png. And yeah, cool. So you see we have our wall in the background of our object. Nice. And you see we have like 2 different textures, 2 different things in this scene being lit. Pretty sweet. One thing I also noticed, ooh, look at that. That's weird. It's like blurry, kind of. Must be being stretched really far. See how they move in relation to each other? That's so cool. But you see, I don't know if you can see it on yours, but it looks like it's really shining on tile because the colors around it. Like, that's kind of interesting. But yeah, so, like if you were walking through this world, you're like, oh, I'm in a bathroom and there's a floating cube, you know, you're walking through it. So look at, like, we're drawing stuff. Now we need to do some boundaries, so it's like, hit that wall. Oh, it looks kind of warped a little bit. That's interesting too. There's a lot of interesting things to take from this, but See, we have all this. That looks good. Yeah. Cool. So sweet. All right, peeps. Until I see you again, I'll see you when I see you.